All right, we are working through 4.3, and let's take a look at these three examples because they're a little bit different than what we were working with this time. Notice that in these examples, in all the ones we've done so far, the unknown has been this number, the variable. But this time, the unknown is this number. And so remember, this is easy to solve if you really understand what this statement means. It's a little weird because, again, this number right here, it looks like it's kind of multiplying, but it's not. It's not multiplying. It's just the number that's plugged into this log. Remember that when you're looking at a log, this number is the base, and here's what you have to remember. The number that you're equaling is the exponent. It's the exponent. And when you take the base to the exponent, that's what gives you the number right here. In a way, this number is kind of the end result, which is weird because it looks like it's multiplying. So rewrite this statement. It's 3, the base, to the exponent is equal to x. And then once you see that it's just this, the answer becomes immediately apparent because all you got to do is just figure out what 3 to the 6 is. So if I grab my calculator, I can do 3 to the 6 equals and just get the answer, which is 729. Okay, so log base 3 of 729 equals 6 because 3 to the 6 gives you 729. So why don't you try these other two examples really quick, pause the video, and see if you can get them. Hopefully you got them. Let's see what this would be. Log base 2 of y is equal to 19. Just rewrite it. Base 2, here's your exponent, to the 19 equals y. So now all we got to do is just figure out 2 to the 19, and we're done. That's probably a big number. 2 to the 19. And you see that these blow up pretty quickly. Y equals 524,288, so just over 500,000. And the reason is because we took a 2 to a power of 19, so 2 times 2 times 2, 19 times. Last one, log base 8 of g equals 2, so just rewrite that. 8 to the 2 power equals g. Again, these two statements mean the exact same thing. You need to be able to go from this statement to this statement and from this statement back to this statement. You see, once you got g equals 8 squared, the answer is just 64. So please understand the connection between these two, because then you can solve all kinds of problems. All right, so what we're going to do now is talk about, now that we kind of have a general idea of what a log statement is and how it works, we're going to look at some really important logarithm rules. All the rules I'm about to write down, you should memorize. Okay, I know that there's going to be a few of them, but you should really memorize them because it'll just make math go quicker, and when you get to higher math classes, it'll just go quicker if you can just immediately analyze things. So we're going to look at the important log rules. I'm not going to prove them because we need to get through them. What I will say, if you're wondering how I know that these are true, they're kind of parallel to exponent rules. And so what I mean by that is we're going to be looking at two logs that are being multiplied together. And you have to just understand that when they break up, it's related to that you can break up an exponent. But I don't want to get too in the weeds on it. Let's just look at the rules. Here's rule number 1 that we've actually already talked about. Anytime that you have a log where it's a base and the number are the same, we already know that that's equal to 1. Here's the second rule. We've already looked at this one. If you have a log of any base and it evaluates to 1, we know that that is going to be 0 because anything to the 0 is 1. So those are the two rules we've already looked at. Now let's look at some other rules. Let's say we have a log of two things that are multiplying. Okay? Log of x times y. It's actually possible to break this up a bit. We always want to try to get simple stuff inside of logs. Here's how this breaks up. It becomes log of x plus log of y. This is a really important rule that you should memorize. Notice that the x times the y is inside of the log. And that's why we can break it up. This doesn't work if like x is timesing out in front. This only works if x times y is inside the log, and then it breaks up to log of x plus log of y. Here's the next rule. Log of x divided by y. Okay, if I have log of x over log of y, that's going to equal the log of x minus the log of y. So you can see that these two rules are a little related. If it's x times y, it's a plus. If it's x divided by y, it's a minus. By the way, if this y and x were backwards, if the y was on top and the x was on the bottom, then it would be log of y minus log of x. So you really should memorize these two rules. Here's the next rule. Say I have a log of x to the a power. This one we can kind of prove with the rule we've already done. If I have log of x to an a power, basically that just means x times x times x times x times x. And so because of this rule, you can just break it up to log of x plus log of x plus log of x plus log of x, and you have a of them. And so in other words, here's what this is equal to. Log of x to the a power is equal to a times log of x. This is going to be really useful to simplify things. So you can think of it as if the entire log argument is to some power, you can think of it as you kind of can bring down the power out in front. Okay, so you can just grab this a power and just scoot it to the front. So I know these rules are different than what we've seen before, but hopefully you'll catch on to them. So let's look at an example. Let's look at something like log of x plus 3 to the h. Okay? Well, remember, based on this rule we have above, if the entire argument is to the h power, you can bring that h down. So h log x plus 3. Like that. And this is h times. Okay? Now here's a question. Can I break up x plus 3 inside of the log? Do we have a rule that does that? Look at our rules. Do we have any rule that will allow us to break up log of x plus 3? The answer is we don't. You cannot write this as log of x plus log of 3, because when is the only time we can do that? When they're multiplying inside the log. So we can only break it up if they're multiplying, in which case you can break it to log of x plus log of y. In fact, this will not simplify anymore. You have to stop here. This is as much as it will simplify. So a lot of doing math is knowing when you have to hit the stop pedal, when you have to hit the brakes, and this will not simplify any further. So don't be breaking up log of x plus something or x minus something. Finally, there's one last rule, and that is, this is one, we don't use this one very often, but it's a good one to know. A to the log base a of x. So a to the log base a of x. It looks kind of weird, but the answer should make you very happy. A to the log base a of x. Remember, an exponent is the inverse function of a log. So if I plug an inverse function into the other function, what should it equal? X. Anytime you have a function and you plug in its inverse, you remember from before, you just get x. So this is used every now and then, sometimes in proofs, but we're not going to use this one too much in this class. By the way, anytime I just write log of a number, like log x, if I just write log and I didn't specify what base it is, then that means I'm using base 10. So this is an important note to just keep in mind. Anytime I make a log and I didn't specify the base, then you should mentally just put in base 10. Okay? So anytime you see that in a book or something, that's what that means. We're almost done. Those are all the rules I have, and you should, this one's kind of an example, but this one, this one, this one, this one, this one, and this one you should memorize. And they're not that bad to memorize, just practice them a few times. All of these rules are parallel for the natural log. So let me just show you the rules for the natural log. Remember that the natural log, when you see that, it means base e. Okay? So when you see ln of x, that means base e. Another way of thinking of that is log base e of x. Okay? But we would never write that. We would only write natural log, but that's what it means. So the rules we just saw are parallel for natural logs. So if I have ln of xy, this is equal to ln of x plus ln of y. So it's pretty much the same as the rule we had earlier. Okay? What do you think ln of x over y would be? Any ideas? It's the same as the rule before. Ln of x minus ln of y. What would ln of x to the a be? Well, you can take that a and just bring it down in front. A times ln of x. Okay? So you can just take that a, and again, that has to be a over the entire thing like we had here. If this was x to the h plus 3 outside, you couldn't bring the h down. The h has to be in parentheses around everything. Finally, e to the ln of x. Okay? Those are inverses of each other. Exponential is the inverse of the natural log function. Therefore, it just equals x. So this page is extremely important. We're going to use all of these rules to simplify some pretty tricky equations. And remember what's the purpose of all of this. The purpose of this is so that we can solve equations with an x in an exponent. And these rules are going to help us do that. So there's all the rules you should memorize. In the next part, we'll look at applying these rules to some examples. See you there.